Hello students. Today I will discuss how to calculate the area by counting squares on a squared paper, that is also known as graph paper. I hope all of you have started this chapter number 11 and the previous two exercises, that is 11a and 11b, all of you have gone through. I have given the solutions of few of the word problems and few of the questions in that WhatsApp group. If you find any problem in those, you can share your doubts with me. I am always there to help you out with that. So today in this video I will discuss the area, how you have to calculate the area by counting the squares. Basically here you have to calculate the total number of squares on a squared paper, that is graph paper. So let us start the discussion. We can find the area of some regular and irregular figures. So at first you have to understand what are regular figures and what are irregular figures. Regular figures are those figures which has a definite shape and size, that is square. It can be square, rectangle, triangle, circle. So these are some of the common examples of regular figures. And irregular figures are those figures which don't have any particular shape and size. It can be of any shape and size. There should not be a particular name for those figures. So I think the difference between the regular and irregular figures are partially clear in your mind, and we have to calculate the area of those regular and irregular figures by counting the square enclosed by these figures on a 1 centimeter square paper. So few points are there. I will discuss those points. So before that, let me show you some of the regular figures. Here you can see all of them are the triangle, circle, square. These are the regular, and here particularly in this question number, from question number 9, 10, 11, 12 up to 16, you can see these are the irregular figures because they don't have any particular size and shape. That's why this kind of figures are known as irregular figures. I hope these examples are there in your mind. So let us go through those points which you have to keep it in mind before counting the area by counting the squares on a squared paper. So what is the first point? The first point is count each complete square as 1. So the first point which you have to keep it in mind is that we have to count a complete square as 1. Let me show you an example. So here you can see 1, it is written. Why? Because we have included this complete figure. We have denoted this complete square as 1. Next point is that count the square more than half as 1. If you find any square which is there and more than 50% or more than half of that square has been included for the diagram, so you have to count that particular square as 1. Let me show you an example for that. Here you can see this cross. Here you can see we have counted this square as a 1. Why? Because you can see that maximum portion of that square is included in this regular figure, which is our triangle, whereas the minimum portion of that square is neglected out. So in this case we have to count this square as complete one. So if you may find any of the square which is included in a particular figure, and a maximum portion of it is there and minimum of it is neglected or missed out, so you have to count that as 1. Next point is our count a half square as 1 by 2 or half. So let me show you an example. Here you can see this figure. As you can see, 50%, that means half of that square is included in the given figure and half of that square is neglected, that is missed out. So for this kind of a square we have to count half. You have to include such type of squares as half. Next one is our neglect the square which is less than half. Now if you may find any of the square in which the minimum portion of that square is included in a figure and maximum portion of it is neglected out, so in that case you have to avoid such kind of square. So there is no need to count such figure, so directly you can neglect it, or there is no need to count those figures and those particular square, no need to consider that one in our calculation. So now let us discuss one example for this. Find the area of the triangle shown on a graph paper. As you can see, this one is our graph paper. I hope all of you have seen graph paper, that is generally green in color, and some of them is red. Quite green color is available. Try to practice. I will suggest you to practice such kind of calculation in that graph paper. Try to have it and draw any of that regular or irregular figure. Try to begin with some regular figure, and slowly and steadily you can find out the area of irregular figures as well. So for that, always these 4 points you have to keep it in mind while you are counting or trying to find out the area in this graph paper. So here, can you name the figure? Is it a regular figure or irregular figure? So definitely it is going to be a regular figure. Why it is a regular figure? As you can see, this one is our triangle, and you have the basic knowledge of triangle. So triangle comes under regular figure. So let us start our calculation. So what is the first point which we have to keep it in mind? That means we have to start with complete figure. Let us try to find out the complete figures. How many complete figures are there in this? That means interior of that regular. This portion is called the interior of the figure, and these portions are called the exterior of the figure. So always you have to count on the interiors of the figures, no need to move on to that exterior to the figure. Clear? So as you can see here, it clearly it is done for you. 1 2 3 4 up to it is there 23. That means how many complete square we have in this triangle? 23 complete figures are there. That means number of complete square enclosed by this figure is 23. So what was our next point? Next point was that we have to count, we have to find out is there any square which is there in that regular figure, and more than half of it is included. That means here you can see those squares and representation. Kindly keep it in mind that try to represent those squares more than half and half squares with any of the symbol. In your textbook here it has been used cross and right. You can use a small circle or a dot. Take cross, whatever the figure it is suitable. Don't go for that complex figure. It is easy to count with a simple circle and dot or tick or right. You can choose as per your choice. So what I was telling you that we have to find out the squares which is included in the figure, and that is more than half. So here those kind of figures are represented as cross. Here you can see that four cross are there. That means these are the squared figure which is included more than 50%, more than half. So in a similar manner, mention those number of more than half square enclosed by the figure, that is 4. What was our third point? It was we have to count the half square. So here it has been denoted as a tick, right. So these are the figures which are half. These are the figures which half of the figures are there in that figure and half of it is neglected. So how many figures are there? 1 2 3 4 5 6. 6 figures are there. Number of half squares enclosed by the figure, that is 6. So and as we have been instructed that we can neglect the squares which is less than half, let me show you that one also. Here you can see that this one is less than half. So this one it is there, and one more you can see these two squares are there which is less than the half. So according to the instruction we can neglect, we can avoid those. So we have followed all the 4 instructions mentioned in our textbook. Now it is our time to calculate the area of the triangle. So as you have calculated the total number of complete square, it was 23. So write down 23 plus more than half, how many it was, 4 plus that means you have to find out the summation of all of them. Next, number of half square, it is half into 6. So here one thing you have to keep it in mind, the represent should be like this, half multiplied by 6. So half multiplied by 6 means what? Here you can go for that cancellation. 6 is divisible by 2, that means 3. So ultimately 23 plus 4 plus 3, 4 plus 3 it is 7, and 23 plus 7, that is 30. And the unit representation, don't forget to mention the unit, because in area whatever it is there, whether it is area or a perimeter, that means in mensuration unit is playing an important role in such kind of calculation. If you neglect unit, teacher may deduct marks for that. So what was the unit? It was of 1 centimeter square. What was the size of that square? 1 centimeter. That means area comes under square centimeter, or you can represent cm square also. Both the types of representation are available to you. You can go through. I hope this particular video will help you to understand and how you have to calculate the area of regular or irregular figures on a graph paper. So again I will discuss few of the examples in our next video. So that's all for today.